We want to look at this question from chapter 16 of the text, where we are looking at this firm which is deciding whether it should buy or not a particular machine. So in this particular question, so the decision in this case is, so the decision here is buy or do not buy machine. Right, that's the decision that this manufacturer has to decide whether it should or it should not buy the machine. And what will this decision criterion be for the firm deciding whether it should invest or should not invest? The decision criterion will be that you compare the cost of the machine, which is given to us as 100,000, compare cost of machine with expected present discounted value of profits it will generate, right? So what you're going to do is to decide whether you should buy or not buy a machine, you're going to compare the cost of the machine, right? The cost of the machine and the expected so we will compare the cost with the expected present discounted value profits it will generate. The cost is incurred today. The profits happen in the future, right? So we can't like compare something that's happening today with something that's happening in the future. So what we do is the cost is today. So we just find the expected present discounted value of the profits, either value today in year T, and then we can just compare them once both are at the same point in time. So that's the goal, right? The goal is that you want to compare the cost which is incurring today, with the expected present discounted value profits, which is the value of all your future profits today, right? And if it turns out, if in this case if it turns out that cost is greater than EPDV, expected present discounted value, cost comes out to be higher. So the decision would be do not buy, so don't invest, right? So that means don't invest, right? So the decision is to not invest, right? If cost turns out to be less than EPDV of profits, present discounted value profits, the decision should be buy the machine, so the decision will be to invest, right? So you want to consider this manufacturer wants to see whether it should or should not buy the machine. What it should do is it should compare the cost of the machine, which is incurred today, with the expected present discounted value of all future profits, because this will give us the value of all future profits today. So now we have both the cost which is incurred today and as well as the value profits today, now able to compare them, because we could not just compare the cost directly with the profits, because the profits are incurring in the future, the cost is incurring today. So what we can do is we can compare the cost which is incurred today with the expected present discounted value of the profits, which is the value of the profits today. And then based on that, we can decide. Now, so this is given to us as this, right? This is the decision criteria. Now let's actually see. Now we're given the cost of machine. This is something that we're given. Cost of machine is 100,000. We're given this in the question over here, the cost. Now we need the expected present discounted value. Now for expected present discounted value profits, the machine will generate. We need that. If we have that, then we can just compare them. EPDV of profits, machine will generate. Now in this case, we have a very special case of what we call static expectation, right? Because see, it says it is expected to generate real profits equal to 18,000 next year. 18,000 2 years from now, 18,001 minus 8% 2 years from now, 18,001 minus 8% squared 3 years from now, determine whether the manufacturer, the real interest is assumed to be constant, right? So there are two things over here that we need to look at. One, notice that you have the same real value profits, which obviously were time adjusted for depreciation, but the real value profits is expected to remain same, and the real interest rate is also assumed to remain constant, right? So this basically tells us that what we have is a case of static expectations, right? So here we have a special case of static expectations in which it's very easy to find the expected present discounted value of your profits. So for expected present discounted value profits it will generate, we have a special case of static expectations. And what is this? The text talks about this. This is where future profits, in this case 18,000. So this is where future profit, $18,000 in this case, right? The real profits remain the same, they just justify depreciation each year. future profit and interest rate are expected to remain at same level forever. So here we have a very special case of static expectations where your future profits are expected to remain at the same level and so are your interest rates, right? Where he told her clearly the real interest rate is assumed to remain constant and we'll do it for three different constant values of the real interest rate. And we're told in the first year, the profits turn out to be 18,000 and next year 18,000, 1 minus 8%, right? So the real profits remain the same, they're just adjusted for depreciation each year. So in the special case of static expectations, the formula for expected present discounted value profits, as the text has derived, turns out to be pi divided by r plus delta, right? Where pi is your constant annual profit. So this is $18,000 of real profit, which remains the same every year. It's just as adjusted for depreciation each year. This is the constant annual profit. And delta is your depreciation rate by which you're adjusting that constant annual profit each year. Like in this year, it was 18,000, it was 18,001 minus delta, then 18,001 minus delta square, so on depreciation rate. And this is your constant interest rate. Right, in this case, so this is the formula that is derived in the text for the case of static expectations, right? So this is 18,000. So here, I'm not plugging in the value of R because you want to do this question for three values of R. So let's just find it generically. And delta, the depreciation rate is 8%, right? The machine will depreciate by 8% per year. Right, so I plugged in the value of the constant annual profit and the depreciation rate because they're the same for all three parts. The interest rate is not, so I haven't plugged that in. So in this way, so we had the cost already given to us as 100,000, but we just found the expected present discounted value profits for the special case of static expectations. Before we compare them now for each of the values of R given to us, just a warning. So expected present discounted value of profits is only given as, so this formula only applies under certain conditions, right? By R plus delta. When one thing that you do need to be careful about is that the first profit is generated next. It's not generated in the same year. So you generate the first profit next year, not in the same year. Right here it says it's expected to generate real profits equal to 18,000 next year. So when you're applying this formula, so it is applied in the case of static expectations, but you have to be careful that the first profit is generated next year, not today. Second, future profits and interest rates and interest rates remain at same level, right? Future profit and interest rates are expected to remain at same level. Future profits and interest rates are expected to remain at same level, so you need static expectations. So every year the profit that you'll adjust for depreciation remains the same and interest rates also constant to remain at expected to remain at same level. Only in this case, so only when you have this case that expected present discounted value profits, which would actually just turn out to be this sum, right? So you have pi being generated next year, which you discounted by 1 plus r, and then you have pi 1 minus delta for the year after that, and that's discounted by 1 plus r squared. And then you have pi 1 minus delta square, 1 plus r cube, and so on. In that case, the sum is equal to pi r plus delta, and the text talks about how we derive it using geometric series. But just keep in mind that this formula only applies by r plus delta for static in the case of static expectations, where future profits and interest rates are expected to remain at the same level forever, as we had in this question. So now let's find, so we found expected present discounted value profits in terms of a general R. Now we can plug in each value of R and find what it is, right? Sorry, so R, right, R here. Then we'll, for each R, we'll find the expected present discounted value of profits, right? And then we will come to the decision buy or not to buy. Then we'll decide whether we buy or not buy. So in the first part, we given R is 5%. So we found expected present discounted value of profits as in terms of a generic R is 18,000 divided by R plus 0.0. Now we'll plug in each value of R given in each part. In the first part, when R is 5%, expected present discounted value profits. When you plug in R is 5%, this turns out to be 138,461.5, which is actually greater than the cost, which is 100,000. In part B, when R is 10%, right, you plug in 10% here, the expected present discounted value profits turns out to be 100,000. So this is equal to 100,000. In part C, it's 15%. And when you plug in 15%, this turns out to be 78,260.87, which is less than 100,000. Since in this case, like we said, the decision is that you compare the cost with the expected present discounted value profits it will generate. In the first case, the expected present discounted value of profits turns out to be higher than the cost, so the decision should be to buy or invest. Right, buy and invest basically. In the second case, the cost is the same as expected present discounted value. You're indifferent between buying or not buying because the cost is same as expected present discounted value. In the third case, the expected present discounted value is less than the cost of 100,000. So the decision should be do not buy, do not invest, right? So in this question, we looked at how a manufacturer firm can decide to whether or not to buy a machine by comparing the cost which is incurred today with the expected present discounted value of the profits, which will give us the value of the profits in terms of today as well, so that we can compare it to the cost which is incurred today.